Number 9, we're given this equation and we're told that it has a root of negative 1 plus 2i. Well, the conjugate root theorem that's in this section says if we have a root of negative 1 plus 2i, we automatically know that we have a root of negative 1 minus 2i. So let me kind of write my answers here. I'm going to put them in brackets, okay? So we already know 2 of the roots, and this is a cubic equation. That means that we've only got one more possible root, because you can never have more roots than the highest exponent in your equation. All right, so how would we go from here? Well, if we know these 2 roots, here's what we can do. These are imaginary roots, but do you remember that if I multiply them together, I'm going to get a real number? That's why they actually occur in pairs. So let's do this. Let's go ahead and let's remember a root is x minus h. That's what a root looks like. So if you know you got a root, you can make the factor out of it by saying x minus, in this case, negative 1 plus 2i, and then we have another root of x minus negative 1 minus 2i. So what I'm going to do is I'm going to multiply these together and get an expression. And then I'm going to divide that into the original to find out, well, what other roots are in there. Okay, the multiplication here is a little tricky. Let's go ahead and simplify before we actually start trying to multiply. This is x minus 1. Remember, you got to distribute that. You can look at it as having a negative 1 out front if you want to. Negative 1 times negative 1 would be a positive 1. X minus positive 2i would be minus 2i. And then over here it's going to be x minus 1 would be a plus 1, and minus 2i would be a plus 2i. So we have to multiply this out, and then we can take the result and divide it into our original equation up there. Okay, so x times x is x squared, x times 1 is x. I'm just distributing here. X times 2i is plus 2ix. Now we've got 1 distributed over all that. 1 times anything is just going to be itself. We could sit here and multiply it all out. 1 times x is x. 1 times 1 is 1. 1 times 2i would be plus 2i. All right, and then I'll use another color for the last one. Negative 2i times x would be minus 2ix. Negative 2i times 1 is minus 2i. Negative 2i times a positive 2i would be minus 4i squared. And you know what? That I squared is the same thing as a negative 1, so negative 4 times negative 1 would actually be plus 4. I'm just going to go ahead and simplify that because I know I've got to do that at some time. I really don't want to recopy all that. Now there's some stuff here that's going to cancel out. The plus 2ix and the minus 2ix, the plus 2i and the minus 2i. Let's see what we have left. We have x squared, and there's a plus x plus another x, so that's plus 2x. And then you've got a plus 1 and a plus 4, and that's a plus 5. If you multiply all that out wrong, you're never going to get the right answer. I know, because I mismultiplied it the first 2 times I did it. So just telling you, you're not the only one if you mess up. Okay, so now what do? We're going to take this result, and we're going to divide it into the original to see what, when I divide that in there, what are my other roots. So I'm going to go to a new slide for that. If you noticed, you were missing the x squared term in the original, so I'm going to put that in. That's x cubed plus there's a 0x squared we have to put in there to do the long division, and then plus x minus 10. And we're dividing it by the result of our 2 imaginary roots multiplied together, x squared plus 2x plus 5. Okay, so here we go. I'm going to use color and switch colors every time I get a new result. X squared goes into x cubed x times. Remember, you're only dividing the first thing here by the first term over here. Okay, so but then you multiply it by everything. So x times x squared is x cubed. X times 2x is 2x squared, and x times 5 is 5x. Okay, but we got to subtract all that. Okay. X cubed minus x cubed, that cancels out, or it adds to 0. 0x squared minus 2x squared would be negative 2x squared. And x minus 5x would be negative 4x. That's a square there. It looks kind of funny, doesn't it? Okay, and then I'm going to drop down my negative 10 here. All right, so now we say, okay, how many times does this x squared go into this negative 2x squared? It goes in negative 2 times, because negative 2 times x squared is negative 2x squared. Negative 2 times 2x is negative 4x. and negative 2 times 5 is negative 10. Okay? But remember, we have to subtract all that. That's how long division works. You get your results, you subtract it from what you had before. So negative 2x squared minus 2x squared is the same thing as negative 2x squared plus 2x squared, so that adds up to 0. Negative 4x minus 4x is the same thing as negative 4x plus 4x, so those two cancel out or add to 0. And negative 10 minus 10 is the same thing as negative 10 plus 10, which also adds up to 0. Yay, it divided in evenly. That's what it was supposed to do. So our roots here, our solutions, our zeros, we could call them lots of different things. If you remember, they gave us negative 1 plus 2i. So we knew by the conjugate root theorem that negative 1 minus 2i was 1, because those occur in pairs. Imaginary roots occur in pairs. And then we just found the last one, we found the factor x minus 2, but remember, in order to find the root, we have to set that equal to 0 and solve for x, and it's actually 2, x equal 2. So over here I should just write 2. So there we go, that we finally have the root. So that's how you would take care of that. There's an example a lot like this one in the book. You might want to look at it and practice it if you think you need more practice. In problem number 13, we're given an equation and we're told to list all the possibilities for the nature of the roots of each equation. Okay, what does that mean? That means, first of all, you're going to look on page 378 at Descartes' rule of signs. What Descartes' rule of signs says is you look, first of all, we're going to check for positive real roots. That's why I've written that up there. I've kind of made a list of the things that we're going to check for, so we'll start with that. If you look at this equation and you say, okay, how many times did the sign of the terms change? Okay, here's what I mean. From this term to this term, did the sign change? No, this was a positive and that's a positive. And so we haven't had any sign changes. But if I go from here to here, it changes from positive to negative. So there was one sign change. Now what Descartes' rule of sign says is if there's that one sign change, then there's one, it matches the number of sign change. There's one possible real root, or there could be less than that, but you have to, if it's less than that, you have to subtract 2 to find it. So 1 minus 2 would be negative 1. Well, you can't have negative 1 roots, or that you can't count them and say, oh, there's negative 1 of those things. So we only have one positive real root in this case. So let's go check the negative roots. For the negative real roots, and I'll do that in a different color so you can kind of keep track with what we're looking at, you take, and everywhere you see an x, you plug in a negative x. Now, if you think about this, are we going to get the same result as before? Oops, I forgot to put my square there. If you have negative x to the 4th power, that would be like negative x times negative x times negative x times negative x. When you have an even number exponent on a negative x here, these are going to team up and be positive, these are going to team up and be positive, and we're still going to end up with x to the 4th. That's going to happen anytime we have an even number exponent on a negative number. So not only is the x to 4th going to be just the same as it was above, but when you square the negative x, you also get a positive x squared. So this becomes x to the 4th plus 3x squared minus 4. It's exactly the same thing as we had up above. And by the way, that's called an even function when that happens, when it comes out the same whether you plug in x or negative x. And that's important in pre-cal and in calculus. Okay, so we've got this. How many sign changes are there here? Well, just like above, that positive to positive, that's not a sign change, but from positive to negative is one sign change. Well, Descartes' rule of signs, the second part of it says that we count the number of sign changes when we plug in negative x, and we get 1. So it's either 1 or it could be an even number less, which basically means subtract 2. Well, 1 minus 2 is negative 1. I can't have negative 1 real roots. You can't count them and say there's negative 1 of those roots. So there's only one negative root. Well, now let's look up here. We know that we have a 4th degree equation because the biggest exponent is 4. That means there's 4 roots. We've only got one positive one and one negative one. Well, where's the other one going to come from? it's going to come from imaginary roots. And you remember they always occur in pairs, so it kind of makes sense in this case that if we say 4 minus 1, we would get 2. Well, that makes sense. If you got one imaginary root, you got another one. So the only possibilities for our solutions in this case is we're going to have 1 positive real root, 1 negative real root, and 2 imaginary roots.